lesson. One, because it's kind of short, and two, because I'm going to teach you a cool way to do something. So the first thing we're going to look at is distance formula. Now, some of you already know the distance formula, which is great. But for those of us that don't know it, we do know Pythagorean theorem, don't we?
Yes.
We know that a squared plus b squared equals c squared. Well, this is where the distance formula comes from. Okay? So let's say C is going to represent the distance between points A and points B. So it's the distance between A and B. Okay? So if we do that, then A is this length and little b is this length. So the distance from point A to point B can be found by doing a squared plus b squared and then taking the square root of that. And normally when we take the square root, we get plus and minus, or plus or minus. But in this case, since it's a distance, we're only looking at that positive length, right? Okay. So I'm going to take this idea and I'm going to throw it into the coordinate plane. So let's say we had this point here, we'll call it A. And this point, no, it is good. And this point here, we'll call it B. And let's find the distance between A and B. Well, if we use the idea we just talked about, what we could do is come in here and create a triangle to find this distance. Okay? And all we would have to do is draw it down here and draw it over here. And you see we've created a right triangle where we could have a squared plus b squared equals c squared. Well, this distance here is, I can count it, can't I? I can count. 1, 2, 3, 4, 5, 6, 7, 8, 9.
You skipped one.
Did I? 1, 2, 3, 4, 5, 6, 7, 8, 9? 9?
Jesus, I'm not counting.
Okay. And then this distance, 1, 2, 3, 4. Okay? So, we can find the distance of this using what we know about the Pythagorean theorem. A squared plus c squared equals c squared. So we would say that 4 squared plus 9 squared equals that distance squared. So the distance is the square root of 4 squared plus 9 squared. That's 16 plus 81. And what is 16 plus 81? 97. And I don't believe that would simplify. Let's make sure I'm correct. I'm correct. Okay, so that's the exact distance. The approximate would be that a decimal approximation for that value, the square root of 97. So the distance between these 2 points is the square root of 97, or approximately 9.85. Yes, sir.
Well, sometimes you have to give your answer in like a simplified radical.
Yes. So whenever asked for exact, that's what I'm asking for, the simplified radical. And if I say the approximate, then you can give the decimal approximation. All right. So let's say these 2 points were not on the coordinate plane. So let's see what this point was. 1, 2, 3, 4, 1, 2, 3. So this point was negative 4, 3. And this point was 1, 2, 3, 4, 5, negative 1. Okay. Could we do the same idea? Let's generalize a little bit. What do we do to get this distance and this distance? Do you see that this is how my x's change? This distance is the change in the x's from here to there. And this distance is the change in the y's. So, what I could do is I could think of this as x2 minus x1. That change in my x's. This I could think of as y2 minus y1. Let's see if it worked. If I do x2, 5, minus x1, negative 4, I get 9. Is Now let's do it here. If I do y2, which is -1, minus 3, retro, I don't get 4. I get -4. But what do I do with that -4?
Make it
I
positive.
square it, and what happens? It becomes the same thing. Okay? So our distance formula comes from using the Pythagorean theorem. In general terms, we can find the distance between any 2 points on the coordinate plane by looking at this horizontal distance, which we'll describe as x2 minus x1, and square that. And then look at this vertical distance, and the squaring takes care of any negatives that might occur.
And that's the formula.
Right, and that's the distance formula.
It looks wrong.
Yeah.
Yeah, it looks wrong.
Okay. So if this is our distance formula, let's do an example. So most of the time when you do distance formula, they don't give you the pretty graph where you can just count. But if I give you a pretty graph, guys, just count. Turn it into a right triangle. Don't do more work than you have to. That's silly. So let's say I just gave you 2 ordered pairs though, like 2, 18, and -20 and 3. Okay, so what would we do? We would choose one point to be our first point. Usually I pick the first point to be the first point. And choose another point to be the second point. So if we did x2, -20, minus x1, squared, plus y2, 3, minus y1, squared. So -22 squared, that is 22 squared is 484, right? You guys didn't memorize your squares up to 25. Y'all just did 1 to 20, right?
We did.
So yeah. Did y'all do 1 through 25?
You did 25.
Okay, what's 21 squared?
21 squared, maybe 13, sometimes 13.
441?
Sure.
Yeah, maybe we don't
We
know.
did it,
We didn't once remember them.
we did like,
I don't know up to like 40.
I remember getting a sheet.
You know this one.
Do you have this stuff?
I did not collect funds today.
Alright, it's
No
fine.
donations today.
I
Had
put
some yesterday.
$5 in, bro.
Thank you. Nice job.
Did what?
Alright, so -15 squared is 225. And so the distance is, let's add them up. We get a 9. We got a 10, carry your 1, 6, and a 7. 709. The square root of 709. Does not simplify. I don't know how I keep picking ones in it. So this is the exact answer. And the approximate answer is 26.63. You are correct, sir. Yep. Okay? Alright, any questions?
No.
Okay, how am I simplifying these in my calculator?
Yeah.
Alright, I looked at the number and I saw it ended in 9, but it's not divisible by 9 because 7 plus 9 is 16 and that doesn't divide by 9. So I really didn't think it had one, but I just wanted to make sure it didn't have a weird factor like 49. So these TI-36 Pros will simplify some radicals. Not all of them, just smaller radicals. Yes, sir.
Why would they teach the distance formula if you could just teach this as the product of the Pythagorean theorem?
Well, when we start talking about a squared plus b squared equals c squared in terms of very large numbers, that usually messes with people and they have a hard time visualizing it. And this is the general proof that always works. But I like the way it's as simple as the Pythagorean theorem. It is. You can think of it in simple terms like your vertical distance and your horizontal distance. That's all you're doing. Okay. Now, our next topic today in the coordinate plane has to do with midpoint and finding the midpoint of a segment in the coordinate plane. Now, midpoint is the middle. It is halfway. How do we find the middle? We divide by 2. Okay? So, you average your x's, you average your y's. You add them up, you divide by 2. That is all there is to midpoint. Okay? Now, these topics are quite timely right now because fairly soon, most of you will be taking the PSAT.
Oh yeah, study time.
Yeah, all my 10th graders will be taking the PSAT. Did my 9th graders sign up for it too? Good, good. No? Okay, alright. You're a different situation. Alright, so if you guys are considering AP classes, they really like to have those PSAT scores for the rubrics. Alright, so we average our x's. So that means add them up. Divide by 2. 6 divided by 2 is 3. We average our y's. Divide by 2. And this gives us 1/2. So, like I was saying, distance and midpoint are 2 topics that could very well be seen on the PSAT. This semester we have a milestone, so I can't spend much time giving you SAT practice, but next semester we do not. So I'm going to start pulling some SAT practice problems for us to work on next semester. It's probably more imperative for my sophomores to get that practice right now than it is for my freshmen, but it won't hurt my freshmen, that's for sure. Do any of your parents make you study SAT books?
Yes, I started last Friday and it was terrible.
Good parents.
She timed me and it was awful.
Oh.
45 minutes for 33 questions on the math class.
Okay, parents see that as an investment because if you do well enough on the SAT, it's possible that you might qualify for certain scholarships, and that's
National merit.
money that won't be coming out of our pockets. Yes, sir.
Wait, so if I don't take the PSAT this year, will I be less likely to be looked at for AP classes?
If you did not take the PSAT, they do use those scores. Are you not taking it?
Well, I haven't really talked to my mom about it, so.
Yeah, they had sign-ups
Yeah,
a while ago.
it's a while.
I won't say you won't be looked at. You'll just have to be stellar. Is that straight?
No. Very cool.
Ah, man. It's so hard to do it when you're sideways. Is that better? No. That
A little
still
farther
doesn't
down.
look quite right, does
That
it?
looks better. Go with.
Ah.
Still.
All right. Okay, you just, if it's still crooked, then you turn your
I think
head.
it's actually the screen.
Alright, so, if I told you the midpoint of a segment was the point 42, and one endpoint was the point 2, -5. Now, obviously, these wouldn't lie on the number line, but I like to think of it this way. It just helps my brain. What is the other endpoint? Now, there's a couple ways we can do this. We can plug it into that midpoint formula. But the easier way is to think about it in terms of vectors. How do I move from this point to get to this point? Because that exact same move will take me to the other endpoint from
At
it.
2, 3.
Okay? So I move 2 horizontally. Very good. And how do I move vertically? 7. Okay? So if I do that same move here, 2 horizontally and 7 vertically, won't that take me to the other endpoint?
6'9".
So the other endpoint is 6, 9. Okay. Do you notice how I used a symbol we haven't used yet? What I'm doing is thinking about this in terms of vectors. Yeah, and you guys will study vectors when you take physics. But this is a very, very, very basic definition of vectors. A vector is a distance and a direction. And when you take physics, they'll call it magnitude in a direction. Okay, so let's think about this same problem on a graph. Whoops. All right. So my points were, my first point was 2, -5. That was one endpoint. And my midpoint was the point 4, 2.
Oh, that was the problem.
So if I think about this as a vector, here to here, I go over this and up this. Okay, a little crooked. So as a vector, what it looks like is this. It is from there to there. That is the vector that represents that distance. How do I move from here to here? Well, if this is the midpoint, I do the exact same thing here to here. That same, hold on, let's see if I can hit it. Okay? So what I would do is go over 2
Up 6.
and up 7. And does that take me to the same point? Let's count. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. 6, 9. Am I there?
Yeah.
I am. So see, that is the vector, and we use that vector notation. We're going to use that again when we partition a segment. Okay, that's it. You have the rest of class time to work on the homework you guys picked up when you came in. Now, what I'm going to do, though, is I'm going to put a bigger copy up here on the screen, because some of those numbers are a little hard to read. And if we need to slide it up and down, we sure can.
Oh.
Okay?
Drop your calculator.
This is back. Sorry.